Hey friends, this is Noah, and I am happy to say I have fine-tuned my first LLM, and I did it for free. And it wasn't actually as hard as I thought it would be. I thought it would be like really, really freaking hard, and it's not. Unsloth makes it really, really easy on Google Colab, and you can do it for free with Google Colab if you use specific models. So let me show you an example real quick. You can see I got metaLlama Q4 here. That's the one that I've been working on fine-tuning, and I'll give you a preface that my training data set kind of sucks, so it's not perfect. But we also have regular Llama 3.1, which this is based on. So I have been trying to get this so that it will write R code for me for meta-analysis. Why? Because I was bored one day and I decided that would be a fun thing to do. So let's see how these two different models answer. So we will say, how do I do a random effects meta-analysis in R? And so what we're going to see here is you'll see my fine-tuned model over here on the left, and you'll see the standard model over here on the right. So it's going to come up with our metaLlama first, and then it's going to generate our Llama 3.1 model, and we can compare. Okay, so while this is generating, I will give you a little bit of information. With metaLlama, I was aiming so that the model would always use metaphor package. Why? Because it's very, very robust and I'm familiar with it. So it'll make it easy for me to check if things are right or wrong. So if we look over here on the left-hand side, we can see that it's using RMA, which is correct for standard meta-analysis. It's got res here, which is just the name of our result, and it's got effect size and variance for effect size in our data set. So that's all looking good. Now it's got an example with built-in data set, and you can see it's basically the same thing, just changing the data set here. Moving on to the custom data, it's loading a data set, then it's showing you an example, and blah, blah, blah. So like here's, I say blah, 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 but it gives you some walkthroughs with other examples. One of the things I do want to mention down here is you can see as it goes on further and further, like this, I'm fairly certain is, it says specify the type of effect size. I don't think that's actually a valid call within RMA. I'd have to check, but this is one of the things that I'm still trying to fine tune. And like I said, my data set was pretty garbage because it was just generated by an LLM. But you can see that overall, this did exactly what I wanted. It defaulted to metaphor, and it did a largely correct call to RMA, and it explained it in a way that a beginner would understand. Now, if we look over here at the standard version of Llama, you can see that they're using the meta package. There's absolutely nothing wrong with the meta package. It's a great package. I just haven't used it very much. So when I started experimenting with this, I was like, oh, I don't know how to use meta. That's going to be a really big learning curve for me. So one of the things that I don't know is when we go down here, I don't know if RMA, for example, is actually a function within the meta package. I know it is within meta 4, but I don't know if it is within meta. So as you can see, these are quite different in the way that they respond, and that is because of the fine-tuning that we did. Now, let me show you how we can actually fine-tune this model, and I'm going to tell you this is not going to be the programming accurate way of describing everything. This is going to be Noah language and just like common understanding of what these different steps do. So here you can see Google Colab, and I know it seems a little bit scary if you're not a programmer because it has coding and stuff in it, but we're going to go through and do like a high-level walkthrough. Okay, just like a really high level walkthrough of what this is. So first and foremost, I'm using a template from Unsloth, and I'll include a link in the description where you can get that. And I really made very minor changes to it. I will point out some of the changes that I made. So as you go through here, each one of these blocks of code you can run individually by clicking this play button. In this first one, I didn't change anything here. This is just installing all the stuff that we need to the virtual machine. So I just hit play and I let it run and do its thing. It doesn't take very long. Then it has this information from unsloth, and here we do actually need to make a change. So I didn't change the max sequence length. I didn't change anything here, and for load in 4-bit, I am using a 4-bit quantized model, so I put true. I don't remember if this is false or true by default. I think it is true by default. And then they give you some examples here. So they say 4-bit pre-quantized models for 4 times faster downloading, and I'm like, oh, that sounds pretty nice to me. And so I ended up using Llama 3.1 8B, and I used the instruct version. So you might be wondering, why did I use Llama 3.1 8B? And the reason is because when I was experimenting with it, like the base model, I shouldn't say the base model because that means something. When I was experimenting with the 3.18b model in Ollama, I found that it could write pretty good meta-analysis code in R already. As you saw in that example, it wrote great code for R using the meta package. I just wanted to use metaphor instead. So I started with that because I thought it would be a good starting point. So all I did was I copy pasted this, and you don't have to use the unsloth models. I just did out of convenience because I'd never done this before. So I copy pasted this into the model name section here, just like it appeared up above. And then I hit play, and it runs all of these things, and you'll see it load up, and it doesn't take super long. So now we need to add our LoRa adapters, and this helps us with our fine-tuning process, as you can see, because we only need to update 1 to 10% of all parameters. So I left most of this the same. Actually, I think I left all of this the same because I didn't understand a lot of these things. So I just left all of these things as default, as they were here. I just hit the little play button when I was ready, and it patches. Or, yeah, and by patches, what I mean is it says unsloth patch 32 layers with blah, 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 blah. So now we moved on to data prep. Now, data prep is the most important thing that I think as like a normal dude trying to figure out fine tuning and how it works and experimenting with it, this is really, really important. And so as we look down here, and let me talk about why this is really important. Basically, if you put junk data in, you're going to get junk data out. And so what we're doing with fine tuning, the normal person language that I like to use, is we are basically teaching it how we like the response to be. So what we have here is an alpaca prompt, and it says below is an instruction that describes a task, blah, blah, blah. Long story short, instruction is your question or your prompt that you would put in. Input is, for me, I ended up leaving this blank. Response is what we end up getting as output from the model, the way that we want the model to respond. So we need to generate a data set like this. Now, this is one area where mine is a little bit different than what yours might be. And so I'm going to skip through this EOS token stuff because I didn't change anything in here. And I'm going to draw your attention to down here where it says load your data set. This section here, just this tiny little snippet, this is going to be a little bit different than what you see in the default code. And the reason is because when I generated my data set, the LLM I was using to generate this generated it as JSON-L instead of JSON. And I just didn't feel like changing it over to JSON. So I just had to change this little tiny piece of script so that it could work with the JSON-L instead of the JSON file. But long story short, you're going to need to generate a whole bunch of these examples. Give me 1 second and I'm going to show you what my data set looks like. Okay, so this is a nightmare to read, right? And that's because it's JSON-L format. But as you can see up here, it's got our prompt, and then somewhere in here, it's going to have our response. And I don't see it as I'm quickly skimming, but you'll see that each basically, I'd call it like a paragraph. Each paragraph is going to have that prompt and it's going to have that response. So how do you generate this in a reasonable amount of time? Well, what I did is I went to a large language model and said, hey, I want to create a data set for fine-tuning an LLM, and this is the type of thing that I want to do. And then it guided me through creating, I basically had it create for me a whole bunch of prompts. And like I said, these are not necessarily great. These are just things that it threw together. And I'll say some of them are good and some of them are bad, and that is why my fine-tune isn't perfect. So you're going to generate that file. And I know I'm not going into instructions on how to do that. And like I said, you can just talk with an LLM to generate that initial file. And then what I would suggest you do is go through it by hand and actually get that data set as you want it. So it's the type of questions that you want it to ask. It's the types of responses that you want it to answer. That's really, really important. That's like the whole foundation of what you're doing here. So if that data set stinks, your fine-tune's gonna stink, right? And so I knew that going in. I knew that my data set kind of stunk because it was all generated by an LLM. I mainly wanted to see how it behaved and know if I'm at least in the ballpark. And the answer is, I'm in the ballpark. Now I need to go back and actually make my data set better, which is going to require me spending time going through and actually doing that. So I'm going to do that eventually. Okay, so one thing that I realized I forgot to mention, and that's why there's this little jump in the video, is we need to actually show you how to get this data set in here. So over here on the left-hand side of Colab, there's this Files button. You can just click and drag your file into here, your training file, and then it will be there for you to use. But let's continue with the coding, because I think once you actually get hands-on with this JSON-L file and look at how it's structured, you'll see it's really not that complicated. It just looks a little bit scary if you're not used to looking at coding because it's got a lot of brackets and hashtags and things like that. Moving on, when you're ready to actually start this, all you got to do is click that play button there, and it's going to import that file. So then we get down into the training step, okay? And like I said, this is all just from the template. I'm trying to point out things that I changed so far. So on this one, the only thing that I changed was this line. And so I think this is 0 by default. I don't really remember. But you can see it says set this to 1 for a full training run. So I did whatever the default was for a quick run just to see if it was kind of working. And then once I realized it was working, I changed this to 1 to do the full training run. And so once you hit play here, this is going to take a little bit of time. And you can go ahead and hit play here as well. And this is going to show you how much memory is being used, all that kind of fun stuff. If you hit this play button, you'll be able to watch as it runs through all of its training steps. So you can see here, it's got this information will come up as you actually run it. It tells you how many parameters are run, blah, 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 blah. And importantly, here you're going to see the number of steps. And so you can change the number of steps, but as you can see here, it's at a max of 60. So it'll run through all these steps, and you can see it does actually go to 60. And my understanding of this, and I'm sure you guys who know more are going to tell me more in the comments, please do, because I love learning from you guys. My understanding is that you want to see this training loss decrease gradually over time, but you don't want it to go too low. You don't want it to actually be 0, because then you're actually overfitting your model. So I was pretty happy with this. You can see it started up here around 1.5, 1.7, and it ended up dropping down to around 0.6. I don't know if that's actually good or not, but it didn't seem like it was overfit, and it actually performed pretty well considering the junk training data I put in, so I was happy with that. This step takes a little bit of time, just so you know. Let's see if we can see how long this took. This took 12 minutes to do the actual training. Okay, so now you get down to the step where you can actually test the model and see how it performs. So this was really exciting to me. You can see here, this is all default. The only part that I actually input is right here. So this is the question that I wanted to ask, because if you remember, instruction, input, output, and the instruction is our actual prompt. So here I said, how do I use rma.mv? And then I hit play, and it comes up and it gives you the answer down here. And you'll see this is a little bit of like a nightmare to read, right? And that's just because of the formatting that I used, where it would actually display as code in a graphic user interface. So I skipped this next block with text streamer because I didn't care. So we get down to here where we want to actually start saving our model. Now, I didn't actually do this step. I skipped this first step of saving the fine-tuned LoRa adapters, because if you note here, as you're reading the documentation, only saves the LoRa adapters and not the full model. I didn't want that. I wanted the gguf file, and that is because gguf file is what I can actually use with Ollama and OpenWebUI easily. I'm sure you can probably use these LoRa adapters too, but I'm not a programmer and I didn't feel like spending time to do that. But I knew how to use gguf. So I continued to scroll down. I skipped this block as well because it didn't seem relevant to me. And I moved down to here. So here you can see saving to float 16 for VLM. I don't use that, so I skipped it. This is the beautiful part, okay? So gguf llama CPP conversion. This is what I wanted to do. So I read through this little note and we get down here. Now, one thing that you'll notice probably is that I hashtagged out all of these ones that I wasn't using. And the reason I did that is because I didn't realize that if it said if false, it wasn't actually going to run. So this step I actually struggled with a little bit the first time because all of these were set to false. And when I hit play, nothing happened. And I was like, I don't understand what's happening. So I went to my favorite LLM, I put in this code, and I was like, why doesn't this actually do anything? And it's like, oh, you have to put true for the one that you wanted to actually run. So up here you have the 8-bit Q8. This is going to be relatively large. Same with the 16-bit, depending upon the model, right? Depending upon the model. But I know that a lot of the Ollama models that I use are actually Q4 GGUF. So this is what I wanted to try because I was familiar with it. No real other reason other than I was familiar with it, and I knew a Q4 KM of the metaLlama 8B was going to actually, I'm sorry, I said metaLlama, that's what I named it, of the Llama 3.18B was going to actually run pretty fast on my machine. So here it said false. I changed the false to true. And then the only other thing that I did was I changed this to be the name of the model that I wanted to use. So I just changed it to metaLlama 8B. Now, when you do this step, it's going to take quite a while. At least it did for me on the free account for Colab. So when I did this, you'll see it comes up with all this information, blah, 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 blah. And it takes, at least for me, it took a pretty good amount of time. Let's see if we can see the total amount of time. I want to say it was like 40 minutes, however many milliseconds this is. I'm not going to do that math right now. But long story short, it finishes it took 20 minutes, 40 minutes, whatever it did, and it gave me my whole model. Okay, so when this is done, what's going to happen is when you open up your files, you're going to see the name of your model here. And when you open that folder, one of the things that's going to be in there is going to be your gguf file. So you can just download that gguf file. And keep in mind, it's going to take a minute because it's probably a couple gigabytes in size. So you can download that file and you want to save it to somewhere you can get it. Now, the next challenging step for me was trying to figure out how to actually use that file. I know that sounds silly, but getting that into Ollama was actually kind of a challenge for me because I couldn't really find many examples of how to do it. And so what I've learned is there's actually two different steps. Okay, so what I'm going to do is I'm going to show you the structure that I have in my folders right now. So let me drag that over. Okay, so this is what I'm using as an Ollama folder. I just created a new folder called Ollama, and you can see I actually fine-tuned a couple different models, but I'm just telling you guys about the llama one because that was the one that I was happy with so far. The other two that I tested out were flops. They weren't very good. So let's talk about this llama one. So you see I have my gguf file. This is what we downloaded. This is our fine-tuned model, but we need to be able to use that in Ollama, and that is not as straightforward as you might think. So you'll see I also have this one that's called Setup Ollama Model from gguf. And so when I open that, you can see that this is the code to actually do it. So there's a reason I did this, and it's because I could not remember. So keep this file in mind. We're going to come back to it in a minute. So let me minimize this. We're going to go back. You can see I have my gguf file. And then I also have this other text document. Okay, so I'm going to open up this text document. It's going to look scary, but don't worry about it. I'm going to explain it. Now that we are here, you can see this looks quite scary, doesn't it? It kind of looks scary. I actually didn't know about this stuff, and I couldn't figure out why my model wasn't working. So what we need to do, I am going to call this just like a template file. So the first thing that we have is from in all caps, and it is saved in the same folder as my gguf folder. So we can do this /, and then I have the name of my gguf file. This is my fine-tuned model file. So I'm saying from this file. Next, we have the chat template here. That's what I'm going to call this, okay? So this seems like a lot to type out, and that's because it is. And guess what? You don't have to. Okay, so let me show you why you don't need to type that out. If you open up Ollama and you go to Llama 3.18b and you click on it, here you can see template. You can just copy this template and drop it in after the word template. So you have to put template, 3 quotation marks here, and then I just copy pasted it in. Whoops. And then I just copy pasted it in. So you can see if I jump back to Llama, you can see it starts with if blah, 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 and then it ends with end, end, end. And when we look at my chat template, you can see it starts with if blah, 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 and it ends down here with end, 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 and the 3 quotation marks. The next thing that you're going to see is this parameter in all caps, and it says stop, and it's got the 3 items here. You get that also from the model card. So if you go here, you go to parameters, and this one is a little bit annoying because you see it says stop, and then it has the 3 listed. You actually have to copy paste those 3, and each one needs its own parameter tag. So you say parameter stop, and then you put it in quotes, and you do that for all 3. Now, last but not least, if you want to actually have a system prompt, you can put that here. So you put system in all caps, and for mine, I just said you're an expert in meta-analysis using the metaphor package for R. So this is a file that we're going to end up saving. I just called it metaLlama because that's the name of my model, right? So if you look again at my file structure, you can see I have my metaLlama file, and then which is the actual model file, and then I created this one text document called metaLlama. Now that we have this set up, how do we actually get this running in Ollama? Well, that's where our other instruction came in. So here I have this note, set up Ollama model file from gguf. We say this is in command line now. So I opened up my command line interface and I said Ollama space create space, and then I put the name of my file, metaLlama Q4 is what I called it. I said space -f, which in my brain, I don't know if this is correct, but in my brain, that's where is it coming from. And then I put just copy pasted the link for the actual file path for that metaLlama.txt, which is this template file. And when you do this, and is going to load that model that you have created into Ollama so that you can use it in things like Open Web UI. So if you can see, I have a bunch of these different local models here, but the one that I have been playing with is this metaLlama, and this is the one that we fine-tuned using this process. So again, I'll say like, how do I do a 3-level meta-analysis nesting studies with, we want nesting effect sizes within studies. And you'll see here, it's going to think about it, and then it's going to load up the metaphor package because that's what I trained it to do. It's going to give us some fake data. It's going to calculate the effect sizes. And then when we get down here, you can see it's actually setting it up with rma.mv, exactly like we want. Over here, it's got study ID and outcome ID, which is putting effect sizes within studies using REML, just like it should for my example. And it gives us a nice little explanation. So if you're probably wondering now, like, well, what does regular llama tell you for this? So I'm going to show you just for completeness, because that was the first thing that I was wondering as well. Okay, so we'll run the same prompt to compare and see how to do a 3-level meta-analysis. You can see that the one over here on the left is my metaLlama. It's structuring things exactly like I wanted to with rma.mv, and it's giving us a bunch of examples on how to actually do this. So over here on the right-hand side, let's see. Yeah, see, it's just kind of babbling a bit before it actually gets to choosing the right package. Yeah, so it has rma.mv from Meta. I don't know if that's actually a package, actually a function within Meta, because I don't use the Meta package. So this is where I ran into some difficulties with the base model, because I know this works in Metaphor, but I don't know that this works in Meta. So anyway, you can see it's quite a different response, right? This is wanting us to use the Meta package, but otherwise the data structure is largely the same. And it's giving us moderators in the first example. And like, I didn't ask for moderators, right? That's not what I asked for, which is part of the reason why I'm working on training this one over here on the left. And I know if you're looking at this, you're like, well, Noah, it's got the moderator in there. Yeah, it does. But like I said, this was a junk data set. I'm still working on creating a good data set to get it fine-tuned to exactly as I want it to be. So we can see that it works. What's the takeaway message here? Takeaway message from this: fine-tuning isn't that hard. I was really scared doing it for a long time because I thought it was complicated and I thought it would cost me money. But using the unsloth template, I was able, as a non-programmer, to go through and figure out how to actually fine-tune a model and how to build a data set that would work. And I mean, honestly, it wasn't really that scary. Like, it took a little bit of time to figure out just exactly how this step worked, where you had to create this chat template. I didn't find very many example videos on how to create this chat template to actually make it work within Ollama. So the first few times I tried to run my model with Ollama, it just spit out garbage. And the reason is because I didn't have this chat template in there. So this is a really, really, really important step, that you include this chat template, you include these parameters, and then you create your model from your gguf file in Ollama using this file as a guide. Okay, so like, this is an important step that I really struggled to figure out. It took me a while to figure this out, that this needed to be done. And yeah, I know you programmers laughing at me. That's fine. You can laugh at my expense. I don't care. So generally speaking, takeaway point: I'm pretty sure you can do this. If I can do this, you can do this. Okay, so if you want to develop a fine-tuned model for whatever your use case is, you can do it. My suggestion is to really spend a lot of time making your data set. Make sure that your instruction and your response are formatted like you want, and the types of questions that you give are the types of questions that you expect to be asking, and the responses are what you want it to be. So that said, the one thing that I want to remind you as you go through this unsloth template, you don't actually have to do every single step. So make sure you actually read what it says, right? So as an example, I didn't need to use this text streamer thing. I wasn't really interested in that. Similarly, I didn't want to save only the LoRa adapters. I didn't want to do that. I wanted to actually save it specifically as a gguf file. So I think as long as you pay attention as you go through here, you'll be able to figure this out, and hopefully you'll be really happy with the result. And I really hope that showing you guys that chat template that you need to create, this thing where you tell it where to get the file and where you get this information for the template and the parameters, I hope this helps you. This was really the biggest stick point for me of the entire process, to be honest. So if I had to like kind of reflect and say, how long did this actually take me to figure out the first time? I think I probably spent an hour working on putting together some sort of fake data set in the beginning, just because I had no idea what I was doing, and then going through and understanding this code, because I like to understand things before I run them. that took probably an hour of chatting with an LLM to understand the basics of what some of these different things do. Because like I was just legitimately curious, like what is a warm-up step? I wanted to learn about that as I went through. So it took maybe an hour, hour and a half to do that. But if you're just running through and click and play, it'll probably be quicker. I'll just say that on the free Colab, and I use the free version, I don't pay for it. When I trained this 8 billion parameter model, the training, as you saw earlier, took maybe 10 minutes, and then it was the actual saving of the file that took a while. And like I said, I think that took probably 20 to 40 minutes for it to actually create that GGUF file for me in Q4 Quant. But again, it was free. I don't really care because it was free. So I just hit play and let it run in the background while I was working on other things. And then when it was done, I went back and I downloaded my file and everything was good. The one thing that I will give you as a warning is I would come back to this page periodically and just kind of scroll because it will time out on the free Colab. It'll time out. So I would just open this back up every couple of minutes and just kind of like scroll my mouse through something like this to see what step number it was at and that kind of thing. And that prevented it from timing out. So that said, I hope this has been interesting for you guys. I know I haven't had a video get posted in a while, but I've just been very busy with real life stuff. And this was really the only project that I've done lately that was kind of fun and interesting and I thought might be of general use to you guys. So if you have any questions, I can't promise that I'm going to be able to answer them because I'm very new to fine tuning. But that said, if you have questions, I'm happy to answer them. I know one of the questions that you're going to ask, somebody's going to ask it, or at least you're thinking it, is going to be something to the effect of like, well, hey, Noah, when can we get your metaLlama file so we can run this custom LLM trained on meta-analysis data? The answer is, I don't know yet. And the reason is because I really did this because I was bored and interested and wanted to test something. And quite frankly, I don't code in R that much anymore because there's GUIs to do it now. So I just don't really have to do it that much. So I don't know. I don't know if I'm going to continue this project. It was really just one of those things I wanted to understand better how it worked. So we'll see. If there's big demand for it, I might spend more time and energy. So if you really want to see and really want to use a fine-tuned model to help you use the metaphor package, please post it in the comments. If there's enough people who want it, I will spend some time and energy putting together a better data set to use it. So that said, I'm going to stop rambling here. I hope you guys have an absolutely wonderful afternoon and a great weekend. Thanks, and feel free to like and subscribe to help support the channel. See you guys.